After talking about the first moment of inertia, let's move to the second moment of inertia. The second moment of inertia is defined in several ways. For the second moment of inertia about the x-axis, it is given by the integral, that means the summation of y squared. So instead of y, we take y squared this time because it is the second moment of inertia. And for each differential area element, you time it with y squared, and you sum them up. What does that mean? As we all know, area is greater than 0, while the y squared is greater than 0, and this, the integral sign, just means the summation. That means the summation of something greater than 0, or to be more rigorous, we know that y squared sometimes can be non-zero, can be 0 sometimes, okay? Then we can know that, okay, it is the summation of something which is non-negative. So we know that this is non-negative. Then the summation of non-negative stuff will also be non-negative. So this is the moment of inertia for about the x-axis. Similarly, this is the moment of inertia about the y-axis. The definition is quite similar to the first moment of inertia, except there is a power 2. And by similar reasons, Ixx is greater or equal to 0, and the same to Iyy. However, for Ixy, xy can be negative. For example, you have an area element located in this quadrant. X is less than 0, y is greater than 0. Then the second moment of inertia generated by this differential area element, dIxy, will be less than 0 because dIxy equals to xy dA. So Ixy, so what is xy? Ixy is not relevant to x-axis or y-axis. It is about the origin. The moment of inertia of the area about the origin, how symmetrical this area is about the origin. So it is such a measure. And there is an important result that you have to know is that, for example, we have x-axis and the y-axis. For this shape, suppose it is symmetrical about the y-axis only, then Ixy will be 0 because it is symmetrical about the y-axis. Also, for a shape, let's modify this a little bit. For a shape which is symmetrical about the x-axis, then Ixy is also 0. This concludes that for a shape which is symmetrical about either y-axis or x-axis, the IXY will be 0. Of course, it would be rather better in case the shape is symmetrical about both x-axis and y-axis, then IXY will indeed be 0 as well.